What if the worst nuclear accident in modern history had actually proven one thing: that physics-based safety works? In 2011, Fukushima changed how the world looked at nuclear power. But it also quietly answered a question engineers had been asking for decades. What happens when everything goes wrong? Fukushima was not caused by a reactor design flaw. The reactors shut down exactly as they were supposed to. Control rods inserted. Fission stopped. The real failure came later. A massive earthquake, a devastating tsunami, and then total loss of electrical power. What failed was not nuclear physics. It was dependence on powered systems. After Fukushima, engineers didn't ask, how do we add more pumps? They asked something far more uncomfortable. What if we remove pumps entirely? What if safety does not depend on electricity? What if operators don't need to act immediately? What if gravity and natural circulation do the work? That question leads directly to the AP1000. The AP1000 is built around one radical idea. If safety systems need power, they are not truly safe. Instead of fighting accidents, the AP1000 steps aside and lets physics take control. Water flows downward, heat rises naturally. Pressure differences move coolant without pumps. For at least 72 hours, the reactor remains stable, on its own. At Fukushima, reactors depended on electric pumps, diesel generators, and human intervention under extreme stress. In an AP1000 type scenario, emergency cooling water is already above the reactor. It drains automatically into the core. No power, no operator action. So where is this design actually being used? In the United States, Vogtle Units 3 and 4. In China, multiple AP1000-based reactors are operating today. And countries like the United Kingdom, Poland, Ukraine, and India are actively studying or adapting this technology. Let's be honest. The AP1000 was not easy to build. It faced delays, cost overruns, and supply chain failures. Westinghouse collapsed financially, but the reactor itself never failed. The engineering worked, the physics worked. The AP1000 proved something essential. Nuclear power can be made safer, not by adding complexity, but by removing dependency. This is Reactor Atlas. One reactor, one story, one truth. See you in the next dive into the heart of nuclear power.